Alright, so let's try number 15 in the linear equations homework. So we want to graph x is 1 plus 2t and y is 3 plus t. So first things first, what do you start with?
Make a graph.
Yeah. Start with one of these thingamahoos. Right? First things first, get something written down. X, y maybe? That's a terrible y. Just horrible. Okay, next.
I started substituting for t.
Sure, yeah. Build yourself one of these things. Oh. This one's a little weird, right? Because it's got kind of 3 columns. But yeah, start with one of these. Fill her in. If t is 0, then x is 1, and y is 3. Okay, so at time 0, we're at the point 1, 3. How do you plot 1, 3? So over 1, up 3, dot, label t is 0. Okay? Then what?
Do it again.
Put 1 in there.
Yeah, pick your next favorite number.
6.
Okay. Fine, we'll try 6. What do you get?
13.
13 and
9.
9. I don't have space for this. Right? I need 13 ticks. I'm going to do 1 because I'm lazy. So if I put 1 in, I think I get 3 and 4. So 3, 4, dot, t is 1. And then what?
Well, you can make a line, but I would do one more.
Okay, it's probably not a bad idea to do 1 more. What's your next favorite number after 0, 6, and 1?
2.
Why not use a negative number so you have one on the other side of the y axis?
Nice. Yeah, I'd probably go with -1. But if you want to do 2, that's cool too. Personally, I'd probably get at least 3 or 4 of these just to kind of be sure, right? So if you plug -1 in,
-1.
you got -1 in for x and
2.
2 in for y. So back 1, up 2. Those look kind of like they're on a line.
So are we just randomly picking numbers to put in there for this system? For now?
Yeah.
Or for always?
I'm okay with this for always.
Okay. That's where I get confused because I always just,
Like-
I know it's super simple, but I'm looking for a different way to solve it.
Okay, so alternatively,
Okay.
if alternatively. So if you want to do an alternative method, another thought you could do is you could look at these and think a little harder.
Okay.
So what that means is there's a piece without a t on it.
Okay.
That's going to be my starting point.
Okay.
That's kind of the analogous to the y-intercept,
Okay.
right? That's really the t is 0 point.
Okay.
You'll note that's this guy.
Okay.
And then another thing I can do is I can look at the coefficients on the t's. And I can think, okay, if I go 1 unit in time forwards, my x is going to go 2 units up, and my y is going to go 1 unit up. You guys see that? So you could think 1t gives you, oh wait, this is crap notation. So maybe do 1, think t, gives you 2 x's and 1 y. So I think, okay, if I'm gonna step forward in time 1 unit, I'm gonna go 1, 2 over,
Okay,
and 1 up,
okay,
right? And then this is 1 time step.
okay, so
And then I could continue that, right?
it's kind of like, it's almost kind of like simulating the slope.
It is exactly simulating the slope,
Okay.
right? So this whole guy, right,
Mhm.
is really gonna tell you that the slope of this line is
Okay,
1 rise per 2 runs.
alright, I like that.
That's cool, that? So either way, doesn't bother me.
Okay.
Another thing you could do is you could eliminate the t. Maybe you could like solve this equation for t, plug the result in for t over here, get into a y equals mx plus b, and then graph that thing.
Okay,
That's a really algebra heavy approach, and it's probably more prone to error than either of these. This is what I would call the like 8th grade kind of like just throw some points at it and plot it. It's not wrong. This is the kind of varsity approach, but whatever.
okay.
Right? Like, just because you learned this in 8th grade doesn't mean it's not effective. I have one more thing. I probably should actually draw the line, right? And as you can see, I have done a crap job of drawing.
Beautiful.
Terrific. If you want good drawings, get a computer to do it. How does a computer do this, by the way?
Graphing calculator?
Yeah, if you have a graphing calculator do this, what is it doing? Does it like know a bunch of stuff about lines?
No, it's putting in a set of inputs and outputs.
Yeah, it's just
Function.
cranking on a million of these. Right, the thing a computer does really, really well is repetitive tasks. Building this table is a repetitive task. So that's all the computer does. It just builds a big table like this and then colors in dots based on that table. Cool.
But what if let's say in the future, cause what if that's not a function?
Oh, what if the picture is not a function?
Yeah, I mean, I'm just saying would that same approach work, cause that's a vector function, right?
Yeah, you can think about this as a vector value function. So this is t's turning into points in R2.
But what if the function, what if it's not? What if it's not working? I mean, your inputs and outputs are just.
Oh, what if you got some garbage?
Yeah.
The good news is right now we're doing lines, and that's not a possibility.
Okay.
If you ended up with something like where you had kind of 3 dots arranged in a V here,
Yeah.
like something that you're not going to be able to connect with a straight line,
Right.
then you might wonder to yourself, did I screw up one of my lines in my table? And probably the likely thing is one of these. You lost a negative sign somewhere. Or you plotted one of the points backwards. That's pretty common. So those are the 2 errors I would look for. Just like silly arithmetic stuff or whoopsie daisy, I just dyslexic to point. Cool?